Lesson 4-1 is all about congruence. And we know that two figures that are going to be congruent are going to be the same size and the same shape. So that's kind of our definition. That's our criteria. Same size and same shape. Well, we've talked about this before in our last unit when we were talking about rigid motions. Two figures are congruent if there is a rigid motion that maps one onto the other. So we're thinking reflection, rotation, translation. Any of our rigid motions are going to preserve congruency. Sometimes we call these transformations congruence transformations because they preserve the congruency there. And then kind of the new thing we're going to study today is a congruence statement. And so we've got an example of one right down here, and we're going to spend a lot of time looking at congruent statements in this video, but on the next page. So we'll kind of come back to this one, but just keep in mind that in a congruent statement, order matters. So we're going to take a look at example 1, part A and part B, and it's just asking us to find a congruence transformation that maps one figure onto the next. So remember, our options are our reflections, our rotations, our translations. And I'm also going to color these because we're starting with RST. So we're starting with the pink one, and we're going to UVW. So we're going to the blue one. So if I look at example A, a translation I know is just going to move up, down, to the left, or to the right. And it looks like it's kind of been twisted or turned a little bit. So a translation is not going to work here. A reflection is like a flip across a line. And a lot of times it's our axes, and this doesn't really look like a reflection. So we can kind of recognize that our figure is just being rotated a little bit to go from the pink to the blue. So all I'm going to list here is that we had to do a rotation. We're going to do the same thing for B, but notice we're starting with our pink shape right down here. And this time, I don't think that it's a rotation about the origin, because this one starts on an axis and then it kind of ends up over here. So it might be a composition. There might be a couple transformations that make this work. I know that if I'm going to have to flip my figure so that this bottom point can move to the top. So if I recognize or use my x-axis as my line of reflection, my point S is what I'm going to look at here is 1, 2, 3, 4 away. So I'm going to move up 4 over here. So a reflection gets us kind of close to this figure, but not exactly, because that point's just going to have to move over 1, 2 to the right. So we can have a composition of maybe a reflection and a translation. That would take us from one figure to the next. So it could be a single transformation or it could be multiple. As long as they're rigid motions, then my two figures are congruent to each other. We're going to do something similar in example number 2, but now we're going to state whether or not we know the figures are congruent. So again, I'm going to color these guys in. I have a pink, I have a green, and we'll do a yellow one here. So our first one we're looking at is from JKL to MNO. So we're going from the pink to the green, and we want to decide whether or not they're congruent. And if so, we want to describe that composition of rigid motions that would take us there. So upon careful inspection of my pink and my green shapes, my green triangle looks a lot smaller. Well, maybe not a lot. It looks smaller than my pink one. And we know that congruent figures have to have the same size. So because they don't have the same size, they are not congruent. And we get to put a frowny face there because we're sad. We kind of wish they were congruent. But because our triangle here got smaller, it's not going to work. But if we look at the pink to the yellow one, so pink to yellow, there may be a couple different types of motions that it could take us from pink to yellow. The one that kind of jumps out to me is if we reflected this across the x-axis, we would look something like this. And then if we reflected across the y-axis, we would land on top of the yellow triangle. So because we have a composition of rigid motions that take us there, we can say, yes, they are congruent. And we can prove it because it's a reflection and a reflection. We could be a little bit more precise here if we wanted. We could include the lines of reflection, but right now I just wanted to kind of describe the motions here, and my picture does that for me well. So the last thing on this page is example number 3, and I want you all to see if you can do this one on your own. Determine whether each pair of objects are congruent, and if your answer is yes, you got to tell me what type of motion happened to take you from one to the other. So you can pause the video and you can come back and check your answers. For example A, I thought this one was kind of tricky, but we're going to say it's not congruent. If you're looking at this just briefly, they look to be like the same shape. But if you look at like the tail of this figure, the tail over here is the skinniest part of our little shape, but the tail on this one is the widest part. So because of that difference here, they're not congruent, they're not the same shape. But these ones over here are. Yes, they are congruent. We've got the same trapezoid. We've just kind of twisted or rotated it a little bit to get from one to the next. So I would say that there's probably a rotation here that took us from one figure to the next. So this is just a little bit of tie-in of what we talked about last unit of how this plays into our congruence. What we're really going to focus on at the beginning of this video is our congruence statements. So we've got a statement over here, and it reads, if you read this kind of out loud, triangle ABC is congruent to triangle PQR. And inside this statement holds a lot of information, so much so that I'm going to color code it. So I'm going to color in my different letters. My first letters are going to be pink. My second letters are going to be yellow. And I thought I had a blue highlighter around here somewhere. Oh, here it is. Our third one's going to be blue. So our congruent statement is telling me more than just my two figures are congruent to each other. They're also telling me the corresponding angles and the corresponding sides that are congruent. So if I start with my first triangle, I know that it has an angle A, it has an angle B, and it has an angle C. It also might be helpful to visualize what's going on here, A, B, C. So angle A is my first letter in my congruent statement. It is congruent to angle P in our second triangle. If we wanted to draw our second triangle out, just pretend like these are the same exact size and shape. Angle A is congruent to angle P. Angle B, you all guessed it, is congruent to angle Q, and angle C is congruent to angle R. So the congruent statement is telling me the two figures are the same, and then each of those little individual angles. But we know that a triangle isn't just composed of 3 angles, it also has 3 sides. So my side lengths of my first triangle are AB, BC, and AC. And these should all be segments. So I'm going to draw the little segment bar over top of them. And they correspond to the side lengths of our second triangle. Now, it's easy to visualize these when we have a picture. We see side length AB right here matches up with side length PQ. But you also can use the congruent statement. AB are the first 2 letters. PQ are the first 2 letters. BC are the last 2 letters. QR are the last 2 letters. AC is first and last. P and R is first and last. Also, you can do colors, pink and blue, pink and blue. So this congruent statement is a little bit like tiny, but it holds a lot of information. So we're going to write a congruent statement for example number 4 right here, and I'm going to color my picture. Well, actually not quite yet. Well, no, I guess I can. I know that angle E and angle S have the same markings, so they are congruent to each other. We have one mark here. I know angle D is congruent to angle T. We have 2 markings in each of those angles. And I know angle F is congruent to angle R because we have 3 marks and 3 marks. And then we can kind of notice that this is just a reflection that would take us from one to the next. So the 2 triangles are congruent. We just want to write the statement. So I've prepped my statement. I've got my congruent symbol. I've got my 2 triangles, and I'm just going to fill in the letters, but I got to remember order matters. So if I go from E, F to D, that's from blue to yellow to pink. I've got to follow the same order from S to R to T. So that this stays true when we're writing our statement. Also notice these little marks on the side lengths are telling me my congruent sides. From blue to pink has 1 mark. From blue to pink has 1 mark in our second triangle as well. So the angles are helpful, but also the side lengths can work too. So now we're going to use this information to help us solve a problem. And we don't have a triangle in this problem, a quadrilateral, but it'll all stay the same. So we want to find values x and y. So the first thing I want to do is find where x is in my problem. X is in this expression, 2x minus 3, and it's this side length from G to H. So in my congruent statement, I have from G to H matches up with L to M. So I'm going to highlight from L to M on my first figure as well. So because the 2 side lengths are congruent, LM is congruent to GH, we know that their 2 values are equal. 8 is equal to 2x minus 3. And now we have an equation that we can solve. If I add 3 to both sides, 11 equals 2x. And then we can divide both sides by 2. X is going to equal 5.5. So our congruent statement helps us match up the corresponding sides and solve for our missing values. Now, y is in this expression right here, which is talking about angle E. Angle E is the first letter of my congruent statement, so it matches up with angle N. I know that angle N is going to equal or be congruent to angle E. We know N has a value of 72, and we know E is 7y plus 9. So using this information, we can set up our equation and we can solve. 72 minus 9 is 63. And if we divide both sides by 7, y equals 9. I like this problem. I like using the congruent statements to help us out there. And then number 6 is going to be a fun one too. We have all of these different parts that we want to pick out from our 2 congruent triangles. But before I even look at these problems, I'm going to color code my picture because y'all know that's my favorite thing to do. So I know Q matches up with V. So I'm going to label Q and V are going to be pink. I know R matches up with U. So R and U are both going to be blue. And then S matches up with T. So S and T are both going to be yellow. So the first thing we want to answer is the measure of angle T. So we want to know what this angle is here. But in a triangle, I have to know 2 of the missing values before I can find a third. So to find the measure of angle T, we need to know at least one more piece of information in our triangle before we can solve for it, which is where our congruent triangle comes into play. Because if we know that angle Q over here in pink is 41, that this angle over here, angle V, is also 41. So once we have that missing angle, we can go ahead and solve. I'm just going to use my calculator here. 180 minus 68 minus 41 is 71. So my yellow angle here and my yellow angle here is 71. While we're at it, we also can fill in angle R is 68 degrees. So T is 71. This one's asking us UT is congruent to. So from U to T is going from blue to yellow. I'm going to put one dash mark here. So the corresponding side is from blue to yellow in our second triangle, or our first one, just the other one. So R to S. Angle V is congruent to, well, that's our pink angle, is congruent to angle Q. TV, from T to V, we want to figure out what this length is. So that's from yellow to pink. So from yellow to pink over here, if we put two dash marks here, this measures 3. So we know that this measures 3. SQR is going from S to Q to R. So from pink, not pink, yellow to pink to blue. So we're going to do the same thing here, from yellow to pink to blue, TVU. And then last but not least, from U to T to V, blue, yellow, pink, blue, yellow, pink, RSQ. So we're just finishing those congruent statements here and matching up our corresponding letters. We're going to do example number 7, and we're going to skip 8 for now. We will come back to an example like this in a future class. So the last thing we want to do here is determine if the triangles are congruent, which means we got to figure out, are the angles the same and are the side lengths the same? So I'm going to start with my sides because they're all marked. I have one pair of congruent sides. I have 2 pairs of congruent sides. And I have 3 pairs of congruent sides. Because of each of these markings, we know all of the side lengths have a corresponding congruent part. If we look at the angles, we have one angle that's marked, but we have to know information about all 3. I know that this angle right here, where they intersect, form not a linear pair, vertical angles. We've got a bow tie. This angle is congruent to this angle. And so in a triangle, if 2 angle measures are the same, the third is always going to be the same as well. Think about this example over here. So we know 2 of the angle measures directly, but we also know that the other 2 pair are congruent as well. So yes, they are congruent. Triangle ABC is congruent to, and now we just have to fill out our congruent statement. A is the one with 2 markings. It corresponds with E. B is the one that's 79. It corresponds with D. And C is the vertical angle. It's congruent to itself. So yes, they are congruent, and this is our congruent statement. All right, so the last little bit of the video is going to be section 4.2, which is all about isosceles and equilateral triangles. So we're going to be able to use these properties to help us solve for missing sides and angles in our triangles. So just to be clear with our vocabulary here, we're going to define some parts of our isosceles triangles. So we know that isosceles means that we have 2 congruent sides, and we call these sides here our legs. And the third side is called the base. So the base is the one that's not congruent. The angles adjacent or next to the base are called the base angles. So that would be this angle here, this angle here. I'm going to color code my picture. My base angles are here in blue. And the angle opposite the base angle is called the vertex angle. And the vertex angle would be this angle here that I have in red or orangish color. And the key thing about our isosceles triangles is that the base angles are, you guys guessed it, congruent. We love when things are congruent in geometry because they make solving our problems really friendly. They're really nice. So we're going to use this information to help us solve for sides and angles in our triangles. And before we get into doing that, we're going to have one equation that's going to be helpful for us, and it's going to be used to help us find those missing base angles. So I'm going to say our base angle is equal to, we're going to start off with 180. We know that 180 is the total angle measure in a triangle. And if we know the vertex angle, then we can go ahead and subtract that. So what this is doing is giving us the leftovers that we're going to split between the base angles. And we know that the base angles are congruent, so we're going to divide it by 2. So this formula here is going to help us find any piece of information we care about. So if we take a look at A, I know it's an isosceles triangle because of these 2 markings here, and I'm given the vertex angle. And we want to find the missing angles down here at our bases. We know they're congruent. I'm going to call them X. So our base angle X is equal to 180 minus our vertex angle divided by 2. 180 minus 68 is 112, divided by 2 is 56. So both of my missing angles here are 56. If we look at angle B, we don't know the vertex angle. We're given one of the base angles. The base angle here in R is 51, but we know that the 2 base angles are congruent, so angle P must be 51 degrees as well. So now it's just as simple as finding one missing angle in a triangle. We know we can do that if we take 180 and subtract the 2 values that we know. So I'm going to type that just in my calculator. And I'm going to get my missing value, angle Q equals 78 degrees. So if we find a base, if we want to find a base angle, we can use this formula. To find the vertex angle, we're just solving for that missing value in our triangle like we have in the past. We can do the same thing, solve our problems, but with our side lengths. So here we just had to be able to interpret which 2 sides are my congruent sides. They're right adjacent to my base angles. So my picture doesn't draw these arrows in or those hash marks in, but I'm going to draw them in myself. I know that GH is congruent or equal to 6x plus 3. So if we want to find the value of x, then we're going to take my 2 values here, and I'm going to set up an equation, and I'm going to solve. If I subtract 3 from both sides, 6x equals 42. And if I divide both sides by 6, x equals 7. So we found the missing value, but we haven't solved our problem yet because we want to find the side lengths. We know GH is 45. That one's already solved for. But what if we found JH? We know JH is 6x plus 3. But we now know that x equals 7. So we're going to do 6 times 7 plus 3, which is 45. And that should make sense to us because we said these 2 have to be the same. So GH and JH must be equal. They're both 45. And then we can solve for GJ as well. It's 4x plus 1. But if we plug in our 7 for x, 4 times 7 is 28 plus 1 is 29. So my missing side there is 29. And then one other thing that we have with our isosceles triangles is a theorem, theorem 4-2, that tells me if a line or segment bisects the vertex angle of an isosceles triangle. So the conditions for this problem we're going to write over here. If we have something that bisects the vertex angle of an isosceles triangle, so we would have to know that these two are congruent, and we would know these two are congruent, then we can say something special. But let's remember that bisect means cut in half into two equal parts. So this green line, which is my bisector of the vertex angle, creates two angles right up here that are congruent as well. So if these conditions are true, then we say that it's also a perpendicular bisector of the opposite side. So that line or segment bisects the angle, and the same line or segment bisects this opposite side. Bisects means it's going to cut into two equal parts. So we've got this side congruent to this side, and perpendicular means it intersects at a 90-degree angle. So if we know this, then we know these conditions as well, and we can put them together to help us solve our problems. So if we flip over, we've got a picture right here, and we're going to do example 3. We want to find the measure of DEG. So I'm going to go from D to E to G. We want to find this missing angle right here. So I'm going to look at the conditions of my triangle. I notice that both of these side lengths are marked C, which must mean they have the same measure. So this side's congruent to this side. So we know this is an isosceles triangle. That must mean that my base angle F is congruent to my base angle D. And then the other piece of information that I have is that this angle is congruent to this angle. So that's what we call a bisector. This line right here is bisecting angle E into two equal parts. And because it's an isosceles triangle, this becomes perpendicular, and it splits these segments into two congruent pieces as well. So because of those conditions, I was able to write in multiple things in my diagram, and now it's going to help me solve. It tells me that DFE, so from D to F to E, is 70 degrees. Well, this angle right here is one of my base angles, so I know angle D must be the same. And now I'm ready to go ahead and solve for my missing angle, because now I can look at just my top triangle. We know this is 70 degrees. We know this is 90 degrees, and now we can find our missing angle. So I'm going to do 180 minus 90 minus 70 equals 20 degrees. So angle DEG equals 20 degrees. And we're going to skip over example number 4. The last thing that we're going to do is talk about our equilateral triangles. So we know equilateral triangles are also equiangular. So that means all three sides must be congruent and all three angles must be the same. But there's something special about these angles, because we know that the total of a triangle equals 180 degrees. And if there's 3 equal angles in the triangle, we can divide this by 3. And we're going to find that each of the angles in our triangle over here are going to be 60 degrees. And this always happens. This is always true. So if we look at something like example number 5, we have A, B, and C is marked as an equilateral triangle. I also know it's equiangular. So this angle is 60, this angle is 60, and this angle is 60. And that's helpful because now I can use that information to help me solve for the measure of BAD. We're trying to find BAD, this guy right here. We are given that CBD, from C to B to D, this whole measure right here is 130. So the missing angle that I'm trying to find is in this second triangle over here. So I want to know a little bit more about it. I know that this total angle is 130. One small section of that angle is 60. So if I subtract the two, I know that this angle is 70 degrees. And now I've got enough information from my diagram here to help me solve, because I have a marking here and a marking here telling me it's an isosceles triangle, which must mean this angle is congruent to this one, and we know the vertex angle. So remember, our base angle equals 180 minus the vertex angle divided by 2. 180 minus 70 is 110 divided by 2. So that tells me X, or BAD, is 55 degrees. We can apply our same knowledge for number 6. This time I don't have any equilateral triangles, I just have isosceles. So I have a marking here, telling me that this angle is congruent to this angle. So I want to go ahead and find those. And I'm given the base angle, so we're going to use our formula. X equals 180 minus 72 divided by 2. 180 minus 72 is 108 divided by 2 is 54. So we've got 54 and 54. Now I want to find angle U. We know angle U and this angle right up here are going to be congruent because we've got another isosceles triangle. Here is congruent to here. So if I know my base angle, then I can find my two missing blue angles here. And lucky for us, this base angle is on a straight line. So we've got a linear pair. The straight line is 180. One side is 54. So if I subtract the two, I get 126. So it's no longer a question mark. My vertex angle is 126. So I'm going to use my formula one more time. This time I'm going to call it y, so I don't repeat a variable. But we're going to do 180 minus 126 divided by 2. And if we plug that into our calculator, y is going to equal 27 degrees. Or I guess more formally we should say, the measure of angle U is 27. And the last thing that I want you all to do is see if you can solve number 7 for me on your own. And I want you to check your answer. Y equals 80 degrees and X equals 40 degrees. See if you can come up with that one. And if you need any help, you can ask me in class. But this is the end of our video.